All right, so I apologize for the lighting, but there are lots of notes on this, so you're probably just going to want to pause if you don't get them all. These are the functions that we are graphing. So we're going to be describing what a sine bt is and y equals a cosine bt. So remember in the last task it was just sine of t and cosine of t, and now they're going to be slightly modified. They've also written it here with smaller letters, with a small a and a small b, and theta is the same as t. So the absolute value of a, that's the amplitude of the function. So when we were graphing in task number 1, the amplitude there was just 1. So anything other than 1, or if there's no number there, then your amplitude's 1. But anything other than that, that means that the amplitude has changed. And so that would change your min and your max. B is the number of cycles in the interval from 0 to 2 pi, and it's not so important that you understand that. Well, I guess if you're looking at a graph, it does make a difference. It's that you understand where to find B. And B is always going to be in front of t, in front of x, in front of theta, whatever they're calling that variable. That's where B is going to be. And then most importantly is this equation right here. To find the period of the function, it is 2 pi divided by that b, the number of cycles. So that's all really important things. And this applies to both sine and cosine, not just sine like the notes say. There's a couple things down here. We talk about amplitude being the maximum or the minimum displacement from the average value. So the average value would be your maximum is big M plus your little m divided by 2. And your amplitude, if you knew what your max and your min was, and you weren't looking at a graph and couldn't just see what it was, would be your maximum minus your minimum divided by 2. And then here is that definition we talked about in task 1. Period means the distance or the length of one cycle. So it's just the time or the distance that it makes to make one cycle or one full pattern as we talked about it. So remember, like sine, the pattern was 0, max, 0, min, 0. Right. So how are we going to use that in this task? So we have a graph here. It's y equals sine 4x at the right, and it's telling us that this graph goes all the way to 2 pi. And so it says that, remember the definition of b is the amount of cycles you have between 0 and 2 pi. So let's just see if the b matches the b given up there. So I expect 4 cycles. So here's 1 cycle, 2, 3, 4. So that is true. So how many cycles occur in the graph at the right? 4 does. And then what is the period of y equals sine 4x? Well, we don't know the period. You could probably get it from the graph. But remember, period is 2 pi all over b. And so we're going to calculate it. So our period is going to be 2 pi all over b is 4. And so the period to make one cycle is pi over 2. It's like pretty much the main way we're going to be using this information from this task is finding the period, finding the amplitude, either from an equation or from a graph. Okay. So here we go. We have one that doesn't give us a graph, but it gives us the equation in this form. So a times sine and 2, and theta is just your variable. Oh, whoop. So let's just put that in as b. That's b. So what would the y scale need to be? So that goes to say, like, what's your max and your min? So the y scale would probably need to go from like negative 1/2 to positive 1/2, or include that. What's the period? So the period equals 2 pi over b, which is 2. So I complete one cycle in a length of pi. So the x scale, goes to that. The x scale would be from 0 to pi. And how does the amplitude affect the graph? Well, that's my max and my min. So if I was just going to sketch this really quick, I'm not asking you guys to do that, but here's a positive 1/2, here's a negative 1/2. And I know I complete a full cycle in pi times. Then I just divide that into 4 parts. So pi over 2, this is going to be pi over 4, and this is going to be 3 pi over 4, because that is where I see my sine pattern. So remember, sine starts at 0, so I would go 0, max, 0, min, and 0. And that is kind of what, ooh, this is a horrible drawing. That is what you would be learning if we were actually in the building. All right. If you need to pause, go ahead and pause so you can get your notes down. Here, I want you guys to pause and just see if you can answer these questions. All right, so hopefully you answered that based on my amplitude, which is 3. I know this negative's kind of weird, and I'll show what the graph would be on that. Then my scale would be -3 to a +3, because we want to include the min and the max. Now the period is a little different, so b in this is 3/4. So my period is going to be 2 pi divided by 3/4. This is where a lot of you are going to be like, how do I do that? It's really 2 pi over 1 divided by 3/4. And remember, when you divide fractions, you take the bottom one, you flip it, and multiply. So we're going to multiply it like this. So my period would be 8 pi all over 3. So that's what this would be. That's also my scale. And how does the amplitude affect the graph? That's my min and max. All right, so again, I am not asking you to draw this, but I do kind of want you to think about it. So here's -3, here's +3. So amplitude always goes on the y. And then you're going to come out here. One period is 8 pi over 3. So you would just put that in. And then you would need to divide that in half. So half of 8 pi over 3 is 4 pi over 3. Divide this section in half. That's 2 pi over 3. This one would be 6 pi over 3, otherwise known as 2 pi. And then what's the pattern for cosine? Do I start at 0 or do I start at my max? Well, hopefully you remember you start at your max, but this negative, it reflects it. So I'm going to start down here at -3, come up to 0, go up to my max, come back down to 0, and back down to my minimum, because this is a reflected cosine graph. All right. Go ahead, and if you need to pause that to make sure you get all your notes in, go ahead and take the time and do that now. All right. You're also going to have one that I want you to try. It's writing an equation from the graph, and so we're going to have a couple of examples of that. So graphs can be in the form of sine of bt or cosine of bt, and the way you're going to figure that out is by the pattern. So remember, sine graphs, they always start at a 0. Cosine graphs always start at a max, or it could be a minimum. When should the a be negative is kind of a clue on this, that it's negative when it's reflected. So what am I starting here? I'm starting at a negative. So, but I'm not starting at a 0. So this is going to be cosine. That's how I'm going to write it. I'm going to start with my cosine graph. And I can see that my amplitude is a -3. So we're going to have y equals -3 cosine. Now we just need to figure out what bt is. So remember the definition of b was the amount of cycles between 0 and 2 pi. Or we could also take the period of it and figure it out. The period is the time for one cycle, and so we can see that the period on this, it starts at a min, goes to a max, back down to a min before it repeats itself, is at pi. So I know my period is pi, and I know that the period equals 2 pi over b. So I can use that to solve. Pi equals 2 pi over b. So I'm going to want to multiply both sides by b. That gives me b times pi equals just 2 pi. Divide both sides by pi, and I can see that b equals 2. So I'm going to write that this is 2t, cosine of 2t. Now the really challenging part is that I can also write a sine graph based on this. And I would write a sine graph by starting where the sine starts, and I'd have to put a shift in. And that is something that was really important to pre-calc that you're just not going to get here. But I'm going to show you just really quickly what that might look like. So you can see that the sine pattern starts here at the 0, and this between 0 and pi over 2 must be pi over 4. And so the way I would write that is y equals 3. I'm not going to reflect it because notice the sine pattern goes up first on that, so it's not reflected. 2, and then parentheses, t minus pi over 4. So you're not going to need to know that, but I wanted you to see it, so in case in next year's class you see it. All right, this one you guys are going to get to try. Same thing. Notice there's some questions to guide you. So go ahead and try this, and then pause it, and when you come back, we will look at that together. All right, so hopefully you had some time to take a look at this one. Should this be sine or cosine? I'm going to say cosine because I don't start at 0, I start at a max. So I'm going to use the cosine. What is the y scale? I mean, they already have a y scale. We don't care about that. But what's the amplitude? What's the amplitude on this? So amplitude, this is my 0. It looks like my amplitude is 0.3. And then what is my period on this? That is a really hard question to figure out because remember, if I have a period as a definition is one cycle, how much of a cycle do I have between 0 and pi? Like this is my max and here's my min. I have half of a cycle. So when do I think that I'll finish? I think I'll finish at 2 pi. Like I think the period in this case is 2 pi because if I meet my minimum here, I got to come back up, get my 0, and go to my max. So if I want to solve for b, I think it's just going to be 1. Multiply both sides by b and divide both sides by 2 pi, so b equals 1. So this is going to be 0.3 cosine of t. All right. This stuff can get a little tricky. I only have you either 1 or 2 times trying this in your few problems that you have for this.